Okay, so let's put all of this into context. Let's look at how the internet works now based on everything we covered so far. Okay, so let's have a look. I'm going to share again a whiteboard, and let's try to figure out how the internet works. Okay, so now we can see that the internet works like this. We have a local network. Okay. Okay. Within this network, we have a computer. Okay. This is the CSUMB network again. Okay. And then we have, as we said, we have a router or gateway here. This is a router or gateway. Let's go to router. Okay. And on the other end, there is another website we want to communicate to. Let's say, again, it's UCLA. Website. And there is a computer inside there. The server, we call this the UCLA web server. Okay. All right. This is your computer. Within the network, it has a MAC address. Okay, and local IP address. And IP address. Okay. Right. And we have UCLA, and UCLA as well has its router there. Okay. And then there are many hops in between. So there is a whole bunch of computers in between, right? The communication between two sites is not direct. It goes through hops. I showed that to you here, guys, when we did a trace route to CNN. Let me share my screen to make sure you see that. Okay. When I did the trace route to CNN, we did not go directly to CNN. We went through several hops or several steps until we reached CNN, right? These are all locations on the internet. We go from one location to the other, to the next, until we reach CNN, as you can see here. Okay, right? So when you are typing the URL of a website, you don't go directly there. You do some hops. We call it hops because we jump from one router to the other until we reach our destination. Okay. Anyway, what happens now is, when let's say I want to access UCLA web server using my website. Okay, so this is what the TCP IP stack will look like. So what happens is, I'm going to divide this into 5 parts. 1, 2, 3, 4, and 5. Okay, so I'm going to be using my web browser. So I will be using my browser. This is my application, right? This is going to be transferred into packets in the TCP layer. So the TCP layer will see that because I'm using my browser, I want to send the information to port 80. Port 80 is the web port, website port. If you want to access the web, we use port 80 usually, right? This is in the TCP layer. Okay. Now in the IP layer, is going to add the IP addresses of the local computer and the UCLA web server. So it's going to be, let's say ours. Let's put IP1, okay, and IP2. Okay, and then this is going to go down to the network layer address. Okay, the network layer address will be used to send this information to the local router. So the local router, let's say, has MAC address 2. So we'll be using MAC 1 and MAC 2 to send the information to the router. Okay, And then the physical layer will contain the actual bits, the actual connections to the router. Okay. Now, this information, this whole packet is going to be sent to the router. Okay. And then the router is going to read this information. The router is going to read this information, and it's going to replace them with other with its own information, right? So it's going to replace it with again, it's the same browser, the same port 80, but the IP addresses will change. Now we'll have the router IP address, router IP, and the IP2 of the web browser. Okay. Right. And then this packet, the rest doesn't matter. All we care about is the IP layer, because this is the layer that we use to communicate between the different routers. Okay. So this packet will be forwarded to the router on UCLA website. The UCLA website will read this information, and based on the IP and based on the on the port, it's going to forward this to the web server. The web server is going to decode this packet and read the data and respond in the same way. Okay, so this is how it works using the protocol. Okay, so the protocol is essential in communicating between local computers and remote computers. Okay, now you don't have to understand the details of this protocol. You don't have to understand these conversions in IPs and everything, because it takes a whole semester to just describe this. So all I need you to know is the role of the DNS and the role of the TCP IP protocol in the communication between computers on the internet. Okay. Any questions? Okay. One more thing, and we will end our discussion of the internet. Okay. Oh. Okay. Now, when we talked about the internet, we talked about, before I talked about the internet, I showed you how the mail service works, right? So you send out an email, and then you send out email, a normal packet, and then you drop it on your local hub or local post office, and it is sent to the other end of the to your whoever you are sending it to, right? Now, in normal mail, if it's not a registered mail, then you don't know whether your packet reached its destination or not. You just put your packet at your local hub or your local post office, and then you trust them that they will get it successfully to the other end. There is no guarantee that it will get there, right? You cannot guarantee when it will get there. You cannot guarantee even if it will get there or not, right? If you want to make sure it reaches there, if you want to get acknowledgement or get a message when your packet reaches there, you need to pay more money. You need to pay additional money. You need to put more cost in order to guarantee that your packet is delivered. Same thing on the internet. The transport layer, the layer that is responsible for moving data between applications, uses two methods or two local protocols there. The first one is called the TCP protocol. The TCP protocol makes sure that whatever data you send is received by the other end. Okay, you are going to receive acknowledgement. You are going to receive a message saying, "We got your message. You are okay. We got your message." Okay. There is another protocol called UDP, or User Datagram Protocol. This protocol is similar to unregistered mail. So you just dump your data and you hope that it's going to get there. There is no guarantee that your data is going to get to the destination. Very similarly to the mail, UDP protocol is cheaper than TCP. It takes less time to send the message. It takes less resources to send the messages to the destination, but there is no guarantee it's going to get there. We usually use this UDP protocol in non-important data. For example, if you are watching a movie using a streaming service, it doesn't matter if one packet is dropped. It doesn't matter if 1 second of your video is dropped. It's not going to harm your experience, right? But if you are sending an important email or you are browsing the website, then it's important to make sure you are sending and receiving the whole data, right? So we use UDP in less important messages, and we use the TCP in more important messages. Okay, so these both of them, UDP and TCP, are used in the transport layer. Okay.